Right. Now that we have our repository imported from Azure DevOps repository into GitHub, we can now actually start to work on improving the automation inside our repository. And to do that, we're going to start evaluating GitHub packages and GitHub actions to automate our workflows. So GitHub Actions is really a workflow automation engine where you can automate and customize custom workflows and any kind of activities that you would want to drive processes on your repository, whether that be like compiling your software, uploading the packages to a package registry, maybe deploying it to an environment, to simple things like maybe responding to a pull request. On the GitHub website, we have a Actions landing page, which gives you an overview of the product. There's some quick start references, some guides, plenty of documentation for getting started. We also have the GitHub Actions Marketplace, where people can collaborate on and contribute to actions that give you extension points necessary to extend your actions workflows. Here we can see that today we've got 8,832 GitHub actions published to the marketplace for you to choose from and drive your automation forward. Some of these, in some cases, might be provided by GitHub, or others might be provided by companies like Azure, Microsoft, various other companies like HashiCorp have things like Terraform automation. And we provide a convenient search-based interface to actually go about finding these particular actions. And then we've got GitHub Packages here, which is the new package management system for hosting your binary artifacts. So those packages that you might build, so your jar files, your WAR files, your containers, can all be hosted within the GitHub ecosystem and directly connected back to your repository. We have support for things like Node.js, Ruby gems, NuGet, Docker containers, OCI compatible containers, and we're continuing to work and expand on those. And once again, you can go to the GitHub docs and get a whole bunch of quick starts of guidance on that. So if we jump back to our repository that we have imported, we've got no actions in place today. We've got the blank slates starter repository that we imported from Azure repository. And if we click on the Actions tab here, we can immediately be taken into some sort of starter workflows that we can choose from to actually get a taste for what we can do with GitHub Actions. Now, because this repository has a Maven POM associated with it, we have already detected that. And we can see here that we've got a Java with Maven provided by the GitHub Actions team workflow that we can just click on this button to get started with. We've also got one for publishing a package, but we're not going to use that one in this context because we're going to build a container as a starter point. Equally, when things aren't necessarily matched on the top level suggestion, you can then delve into the community provided starter templates that we have. So we have here a bunch that are popular. So we can deploy to Amazon ECS, deploy a Node.js app to Azure Web App, to other things like continuous integration workflows specific to your languages. And of course, you can click on that and expand them and see what fits your bill. You can equally use one of these as a starting point and modify it to your needs. So we're going to jump into the Java with Maven workflow. And by clicking this button, it immediately has created us a .github workflows and a maven.yaml file. So all GitHub Actions workflows live inside this .github workflows directory. Then it's pre-populated this using the template. And we can see here that it's given it a name of Java CI with Maven. We've got a bunch of triggers, which is to pushes to the main branch will trigger this automation that we're providing, and any pull request to the main branch will also do the same. Then we have the jobs section, and the jobs are the set of steps that you want to actually execute that will be farmed out to a runner. If you want to do a lot of parallel builds and things like that, then you would separate those across those job boundaries and connect them together using that type of approach. So here we have a single job called build. It's going to run on Ubuntu latest. So at the moment, this is Ubuntu 20.04. And then the steps that it's going to execute, we have the checkout step. We're then going to use the setup Java GitHub action step, which is going to install Java 11 for us using the adopt variant of the Java SDK. And then we're going to execute Maven by just executing a command line of Maven package, and we're executing in batch mode, and we're specifying the POM file. So if we start a commit with that and commit that to the main branch, we should see that immediately gets created inside a repository. But in the Actions tab now, we should see that the workflow has executed. So here we have our workflow executing in real time. We have this nice visualization for us. There's only one job, so hence we have just one block. And if you click into this, you can see the individual steps and the real-time logs that are flowing through this. So because this is Maven, it's now downloading a whole bunch of plugins necessary for it to actually operate and execute our desired build. It's now running our unit tests for us, which we just saw passing. We get to the end and we have a successful build. So with that done, we now actually have a continuous integration type approach where we execute Maven package, and it's now building our war file for us and running our unit test. So this is an absolute bare minimum workflow that gets us up and running. So that's a good starting point. But where do we go from there to take this up a notch? So if we go to this repository, which is a copy of the previous one, but with some pre-populated actions workflows that we've built out. So here we have a build test publish workflow that has been included in this repository. And we can see that this actually is a little bit more complex and there's a little bit more going on with this particular workflow. So what we actually have here is we've got a matrix build. So we're executing our build across multiple operating systems using the same version of Java. And ultimately, we have a build container step now where we're building a Docker container to actually publish our application and work with it. So the other aspect that we can look at here is at the bottom, we also have these artifacts which are attached, and we can see our war file is now actually being stored as build artifacts for this particular workflow that we've published here. So let's have a dive into this workflow and see how we've achieved this. So like the previous one that we had before, it's a similar type of approach. We have a nice convenient name. So we'll call this build test publish, and this is a nice human readable form. But on our triggers, we have push and we have pull request. And we've removed the restrictions on the main branch in this particular context because we want to execute our builds continuously on any feature branches or pull requests that may be generated on our repository. Then within our jobs, we've actually separated our workflows into two separate sections within the jobs. And then the first job here, which is build, has a further creation of multiple jobs using this matrix strategy. So we've given this an ID of build, we've given it a name of build, but we can give that a name that makes sense from a human readable perspective. And then this time around with the runs on, we're using this context notation, which is matrix.os. And this is coming from our strategy. And our strategy on this particular build is to not fail fast. And the reason for that is to make sure that we execute on all combinations of operating system and Java that we want to execute on and collate all those results back before we actually fail our build. If, on the other hand, you had types of workflows that if one of them failed, there's no point in executing any others, we could set this to true. And then we define the matrix. And the matrix here specifically for our build is to provide the combinations and permutations of things that we want to execute across. So in this case, we want to execute across two different operating systems using a single version of Java. This, of course, will then generate in Ubuntu 20.04 with Java 11 and Windows latest with Java 11. We could equally add a Mac OS version of our runner here, and then we would have three. If we added another version of Java, so maybe we wanted to test under Java 14, then we would have 4. So we would have 2 versions of Java and 2 versions of the operating system here, which will give us 4 concurrent runs within our matrix. And the great thing is that you can just modify that matrix strategy and nothing else in your workflow has to be modified, and they then share the common aspects of the execution, the build steps that we're actually looking to leverage. We have some outputs defined here, which we will come back to in a moment. But here we have our steps of what we're actually doing within our job workflows. So we're checking out our source code like we did before. So this is using the GitHub provided actions checkout. We set up the JDK like we did before. So adopt, this time though, we're specifying specifically a JDK, but we're also using the context language to inject the version of Java from our strategy that is defined above for our matrix. Now, before, when we executed using the previous workflow, we saw that Maven was downloading a whole bunch of files from the internet, and this is what's required for it to actually execute and perform its build. Now, it would have to do that every time. So to speed this up and to utilize the caching mechanism within GitHub, we're using the actions cache, and this is yet another provided GitHub action. And we specify a path on disk that we want to cache. So in this case, we want the Maven 2 repository that is going to contain those downloaded artifacts from the internet that we need to bootstrap our Maven environment. We provide a key, and this particular key is built upon the context of the information of the execution environment. So we've got a starter, and then we're using the version of Java, the runner operating system, and then we're using this hash function on our POM. So if we have no changes in our POM, i.e. there's no changes to our dependencies, then the cache will be 100% valid for us. Anything that's in that cache will already have all the files that we need to execute. But the reason that we've organized this in this way is that maybe you make a modification to one of your files, one of your dependencies, for instance, then this hash won't match, and then we wouldn't get a cache hit. But what we've done here on the restore keys is that we want the most specific match first to be returned to us if there is a match for that cache. But then we start dropping these properties that we've added to the name here. And so if we've modified the POM, we'll take any one that we've previously cached that has those files in it, knowing that it isn't a direct match. And then we would let Maven continue to then download the extra bits that it didn't already have, but we would still gain the benefits of the caching of the plugins and the open source aspects of the execution environment. So that's why we have multiple store keys specified here. If you wanted to operate on a specific match, then you would just utilize that first restore key. After that, we are now calling using GitHub script, we're calling a custom script that we've put inside our repository. Now, GitHub actions can be extended using marketplace actions. You can write Docker-based actions or JavaScript-based actions, but you can also put small JavaScript action scriptlets inside your workflows. And using anything under this script indentation, we can use the JavaScript environment that GitHub gives us to actually execute against this. And with GitHub script, we also get access to the core toolkit. We get access to a hydrated GitHub OctoKit wrapper, so we can make HTTP, REST API, and GraphQL API calls if we desire, and some other functionality. But sometimes Bash scripting or PowerShell scripting doesn't quite cut it, and you can fall back to using the JavaScript environment to extend your build. In this case, we've got a script which is checked into .github workflow scripts, and it's called buildparameters.js. And we will take a look at that now and just to see what's in that script. So in our workflows scripts, we have this build parameters, and effectively this is just a simple script that we are using to interact with the actions runtime to generate some dynamic or specific aspects of our version numbers and shars and things like that that we can then use later inside our builds. So the first thing that we're doing is we're generating this short shar. So we're taking the input of the commit shar and we're shortening it to 8 characters, and then we're setting this as an output of our action step under the parameter name of GitHub _short_shar. And this means that we can reference it in later parts of our build to maybe pass it into Maven or to particularly contextualize certain other aspects within our workflows as we see fit. We're also extracting the GitHub reference. So in this particular case, it's the reference of the branch reference that we're actually getting. So it could be refs heads main, it could be the name of our feature branch, it could be the pull request merge branch, so on and so forth. Then we do some manipulation on that branch name to just get the actual physical branch name, because we don't want that full path. So if we commit to main, we just want that to be main. So as such, we're doing some manipulation around that and shortening that to specifically just the short name of the branch that we're interested in. We're making a call to a function within our script. So once again, you have the full power of JavaScript available to you. And then what we're doing here is that we're practicing a continuous delivery type approach. So we need to incorporate things like the shar and the branch, and potentially our dash snapshot type interaction within our Maven POM here to give us our dynamic version number to ensure that we have always have a unique version number. So that means that we could potentially always deploy that binary aspect of our project to an environment and have it traceable back to the source code. Of course, we can't have things sort of overwriting, and the Maven default of version number dash snapshot doesn't quite cut it for us here. Our Maven POM is set up to use three dynamic aspects that we can inject into. So revision, change list, and SHA-1, which gives us a dynamic version number available to us as part of our builds. And we're using this set output to set other nice things like organization name, repository name. Some of these are available in standard forms within GitHub, but we're putting them under more easy to use names to remember. We're also generating a container name and container owner for our deployment purposes later in our workflow. So if we jump back to our actual workflow that we were looking at. So here's our workflow again. So this particular step that calls that script, of course, we had to run checkout for it to be available on disk, which it is. And this particular build step has an ID associated with it called build parameters. And because we're setting those outputs from within that script, it now means that we can call steps.build parameters.outputs.output name and use that in later parts of our build, which is exactly what we're doing in the next step with Maven. So here we have our Maven build, and we're calling Maven package as we did before, very similar to the previous starter workflow. But now we're also injecting in some extra parameters to the Maven workflow. And this is giving us some property injection as well as some control over our version number. So here we're passing in that SHA of the shortened SHA. So rather than it being the full length, it's only going to be an 8-character long SHA. And the change list is that special Maven function which decides whether or not to include the branch name and if there's a dash snapshot on the end of the build number. Because we're going to be practicing continuous delivery here, we don't want dash snapshot releases to occur from the main branch, but we do want them on all other feature branches and pull request associated artifacts. And then ultimately, when that Maven execution has completed, there'll be a WAR file. And what we're doing is we're saving the artifacts of the build and attaching those to the execution. So before we saw that we had 2 WAR files associated with our build, and this is using the upload artifact. We're giving it a name, so we're in full control of the name of Bookstore and the Matrix OS, so that's Ubuntu 2004 and Windows latest, the matrix of Java, which in our case is -11.war. And we're targeting the actual war file that we're building, which is underneath target and bookstore.war, and this is controlled from our POM. So our POM will always just output a bookstore.war file. So that gives us the first part of our build. And if we go back to our actions and just recap on what it is that presents as we execute, that gives us that first part of the matrix build here, and as well as these two artifacts that are attached to our build. So then we've got this build container. So if we go back and take a look at our workflow, after we've got those war files, we need to put it into a container that we can then store in GitHub packages. So we have this separate job. So within the job nesting, we've just gone through build, and now we've got build container. So build container is going to build our container image for us, and then also upload it to GitHub packages. So our ID for this is build container. It has a nice human readable form of build container. It's going to run on Ubuntu 20.04 only. And the reason for that is that the Docker and container-based build system is only available on Linux-based runners. If you provided your own self-hosted runners, you may be able to actually get around that limitation. But within the container, within the GitHub Actions ecosystem today, all container type builds need to execute off an Ubuntu runner. We've got this guard that is present here on our project, and this is just to protect us from Dependabot. And the reason for this is that Dependabot doesn't have access to secrets. But within this particular build container, we need access to our secrets so we can perform the authentication against the GitHub package registry to publish our package. So what we need to do here is protect ourselves from any jobs that might be triggered by Dependabot. At the moment, there is no Dependabot integration within this repository, but this is a guard that if we did enable it, it would stop this limitation from failing our builds. Then the next thing that's kind of interesting to point out here is that this job has a physical requirement, which is defined by this needs. So this is stated that it needs a job of build to have successfully executed for us to actually execute this build container job. So going back to the definition of our build job, we've got the idea of build, and we've got these outputs. And these outputs here allow us to communicate across the divide of jobs. So as part of this execution of this build workflow, we are also setting these outputs, which expose these values across that job boundary. So this will make the build container able to use these values to actually populate its steps and provide some kind of configurability within that workflow. So before, as we went through the script, we've defined this container name. So that's one of the parameters that's coming from the build param step, and we're passing that through and across the job boundary. Equally, the container owner is done the same, and the version number of the actual physical build from the Maven execution is being carried across. So once again, this defines some outputs that we're not going to use, but these are some useful outputs that we might want to actually share across boundaries as well. So maybe you want to add other workflows later. We're doing a similar type of approach here. Typically, you wouldn't do this unless you have something that's used downstream of it, but this is actually a modified version of a more complex workflow that we'll get to later. If we now look at our steps on what we're actually doing within this job for building the container, we have to check out our source code again. And the reason for this is that each job executes on a different runner. So of course, we have to initialize ourselves to get the latest source code that is specific to the commit that we're trying to build from. Then we're going to download the WAR file that we generated from the previous build step. And here we're using the GitHub provided actions download artifacts. So this is able to then download the artifacts that we previously stored in the previous job and attached as artifacts to our build. And here we're using a hard-coded string to get the Ubuntu WAR file we're executing this on the Ubuntu, but we could equally get the Windows WAR file if we wanted to here by just changing the Ubuntu 2004 to Windows-latest. And then we're exposing that particular file to a target directory. So we're going to create a target directory, download that WAR file, and we're going to place it inside that directory. Then we have a step here, which is defining some outputs. So as I spoke to before, we were using JavaScript for the more complex aspects. Here we're using a context function to communicate with the GitHub Actions ecosystem to set output. So instead of, like in the JavaScript aspect of calling core.setOutput from GitHub scripts, here we're just executing something on the command line and using the syntax of the : set output to call the equivalent set output function. Here we provide a name, so this will be the name of our output variable that we're interested in. There's another : and then you provide the value. And in this case, we're using the values that were passed to us to build up the container name and the version number, so we can then use that in later parts of our build. We're equally isolating the container name, and here we're just actually mirroring what was there, but this gives us a shorter syntax and keeps things together. And then we have, of course, the container and version tag, which for us is just the specific version, but by doing it with this under this nice unique name, in the future, if it changes, we don't need to go through and change it in multiple locations. The next step we then operate on is that we're going to want to publish our container when it's built. So to do that, we need to log into the container registry that we're going to use here. Now, here we're using the login action provided by Docker. So this is a community provided action that Docker has built and given back to the community via the GitHub Actions marketplace that supports not just Docker Hub, but all container registries. So Azure Container Registry, Google Container Registry, ECR from Amazon, the list goes on. But also it supports the GitHub Container Registry. So this is the GitHub Packages Container Registry that we're going to authenticate with here and upload our container to when we've executed our build. Here we're using the username that was passed through to us by the GitHub Actions workflow. So whoever has actually executed this particular workflow will be the actor. So if it is me running it, then and by doing virtual the commit, this will be my user handle. And then we're using the provided GitHub token for the Actions workflow. So this is a limited scope token that's provided out of the box with every GitHub Actions workflow. And you can tweak the permissions set that is available on this. Here within this workflow, we're using the defaults, but you can limit the access to this within your organization settings or even potentially within the workflow itself by using the YAML file that would composing the workflow in. After that step is finished, we're using yet another GitHub marketplace action provided by Docker again. This one is going to set up the BuildX environment, and we're specifically wanting version 0.5.1 of BuildX to build our container. Now we have some caching of the layer. So just like we did with the Maven build prior to this, we are using the Actions cache to build up and maintain a cache that we can restore if we have an exact match on our cache key. Here we are only interested in an exact match, and this means that if we were to rebuild the resultant container over and over again, we wouldn't be building from scratch every time. So this will give us our previously cached layers. Then we have, once again, another Docker community provided action, which is the build push action, which is actually going to do the Docker build and push to the container registry, which we had previously authenticated against. We are providing a context of dot, which means it will execute within the checked out source files that we have provided. And then we're passing in a number of build arguments, which are specific to our Docker file that we have inside our repository. So the Docker file is committed into this repository, and it's got some build arguments that we are influencing as part of our build here. We also provide the tags using the outputs of the previous defined step. And this means that we only have to change these in one place, and we don't have to, if we were to change the way that we reference version numbers and that in the future, we can just reference these outputs that we've defined under this define container attribute step prior. So this is gives us our tags that we need from, and then we're influencing the cache here to use the cache that we have restored from our previous runs, if there was one there. We're now working around the bug after that by using some bash scripting to stop the explosive growth of this cache, because there is a bug if you don't follow this approach. There's a couple of tracking issues here, and we can follow these and remove this once the bug gets fixed in GitHub Actions. Then finally, what we do is we're publishing a commit status onto the commits inside our repository upon a successful build. So here we're going to generate our own custom status that will show up inside the GitHub UI, and it's actually going to have a name of container image publish -app, and the description, so the value that we might be interested in pulling back later, will be the container name and version tag. So this gives us a very tight link from the commit that we are executing from our workflows from back to the actual container that was built alongside that particular build. And if we take a look at the actual execution of this, you can see all the individual steps for this workflow that will execute, and we get to this publishing a container status at the end using a community provided action. We can see that that executed, it was successful. And if we then go back and look at our commits here, so this is our commit that we had before, and we've got the check mark on this as all our checks passed, but here we can see our container image published, and the description, which is very tiny on the screen there that's popped up, is the actual name of the container we built, in this case bookstore-actions, and the version number being 100-A069CAE4. So if we then look at our packages, we can see here a nice integration with GitHub packages. We've got our bookstore actions container is here with our version number. We can click on this and this will take us into the container registry. We can see a nice usable URL here that we can copy and paste to pull this from the command line. We also get a report of all the tagged image versions that exist today, as well as the ability to manage it. And because of the way our Docker file is set up with some labels that are defined within it, we get things like linking to the README. We also get the linking back to the repository here implicitly done for us. So we get all this nice connectivity of having the package, the container, and the source code all linked together nicely, as well as some stats and metrics on downloads. And we can see that we're not very popular here. Nobody's downloaded any of our containers. This is also scoped as internal, so it's not available outside of our organization that we're operating in here. And with that, we've got like a fairly rudimentary now integration of GitHub Actions. We've now got a continuous integration approach with the earlier aspects of continuous delivery. With this to truly be continuous delivery, we would need to add the ability to publish into a environment to host our source code. And that's part of our more complete repository that we've got here, which culminates in a far more complex set of actions. We have a larger number to pull from, but we can potentially, in a further extension of our workflow on this build test publish that we just had before, if we take a look at it, we have the final step, which I was providing those outputs for, that didn't seem to make a lot of sense in the context of what we saw before. But we can have a final step that will actually go and create a GitHub deployment for us, which will contain some metadata that we need to encapsulate a request to deploy this into an environment. So with this type of extension, we now have the ability to utilize GitHub's deployment mechanism or the new actions environment mechanisms to actually now deploy this to a physical cloud-based environment. And this particular repository is using Azure as its target audience. Actually, if we go to the production, and if we take a look at this, we've got a workflow specific to deploy into this environment. And if we take a quick look at what we're doing within this, we have a deployment details where we do some unpacking using a script, once again, that's encoded inside our repository, a piece of JavaScript that will take that GitHub deployments API request, unpack the contents of it, provide it as a bunch of outputs, and then we can execute a deploy phase as part of our execution where we deploy this to Azure. And here we're using Azure provided GitHub Actions. So once again, Microsoft and Azure have provided us a whole bunch of starter action steps that we can leverage within our workflows to integrate the deployment aspects and the interaction of our Azure account within our GitHub Actions workflows and our repository automations. So here we log into Azure, and here we're using some credentials which are provided specifically across our organization that we can reuse. So this is using the secrets management system within GitHub to access an organization secret. Secrets can be stored at organization repository level and even environments, which is a new feature that's currently in beta with GitHub. So you can have secrets associated specifically to environments that are only available when you're deploying to those environments. And then we are calling some command line activities. So here we're using the Azure CLI command line tools built into the Actions runner, and we're creating a web app, we're updating it, then we're using another action step to feed in some application settings to allow us to authenticate with the GitHub container registry and pull down the necessary image for this deployment. And then ultimately, we then perform the deployment using another Azure provided GitHub Actions step here. When that's complete, we then sit and wait on that URL for our website to become available. So this is our container with the WAR file built into it. And then we report a success status back using some now inline JavaScript here. So this is what inline JavaScript looks like. And the reason that the others were using contain scripts is that they were significantly longer than this. And as such, don't read that well, whereas even this is getting a little bit long, but it showcases it's quite easy to put this JavaScript within your workflows. And with that, this particular repository will, because it's using the environments, we can see that we actually have multiple environments present here. These environments give us a link to view the deployment, and here we can see our bookstore running in Azure, all deployed for us using GitHub Actions, GitHub packages, and integrations with Azure to host this for us. Right, we're back. So what do you think of that, Sam?
I think it's superb. I love seeing how all the different components work together to get it all posted through. I really quite like the YAML interface in in GitHub Actions. It's slightly different syntax to the YAML structure inside Azure DevOps, but it's a very similar kind of practice going through it. It's also worth just kind of noting while we're talking about that if you want to use a user interface, a drag and drop user interface, Azure DevOps Pipeline still has a classic interface where you can do that. We're just not going to be showing that today because we wanted to show off some of the advanced security features of GitHub.
Indeed. The other thing to sort of point out, there was a question in the chat as we were going through. I tried to highlight it as we went through, but while we're using GitHub packages here as our container registry, we can interact with any container registry. The only conditions that we face when actually writing these workflows is that the runner needs to be able to, of course, access the target registry. So if it's facing cloud facing or on the internet, that's very easy to use that with the GitHub provided runners. Also to point out that all of this was shown using the GitHub cloud-based runners. But you can actually provide your own self-hosted runners that you run inside your network boundaries. And using that, you can potentially access private registries that you may have behind the firewall. This is all done via deploying your own pool of self-hosted runners.
That's a really great point, Peter, because I know a lot of my customers have Azure Container Registries locked down to their own private networks. So being able to run your own runner for GitHub Actions inside your network behind your firewall still means that they can access those Azure Container Registries as well.
Another question that's popped up along the way when that was going was asking some questions around debugging. With GitHub, with GitHub Actions, this was a fairly straightforward sort of workflow, but I would very much encourage that rather than reaching for the sky when you're actually trying to build these things out, is to contain these into smaller chunks and slowly add your features and let it grow. GitHub's making some moves to make it easier to sort of template and make some reuse of workflows where you can share them across your repositories today. But currently, everything is contained to the repository that you're working in, and it will be next quarter before we start to see those templating functions reach the platform. There are some third-party utilities that are available and provided by the community. One of them is Nectos Act, and that does provide a very limited environment for actually testing your workflows locally. So you could potentially leverage these tools. It's got some Docker containers that encapsulate some of the tool sets that the runners have, and you can execute your and debug your builds locally on that machine. Your mileage may vary depending on what actions steps you're actually using and composing, but it can be very useful.
I love that that Act library. I've not used it myself, but it sounds brilliant being able to locally debug things and just step through it. I wish we could do that with Azure Pipelines, if I'm honest, but I don't know the way to do it. So another great example of some of the new features that are coming out and around this. It's great.
Yeah. The other things that you can actually do also is potentially just log things out to the console. When things get pretty rough and hairy, you can always fall back to Bash or PowerShell scripting to dump whatever information that you desire.
Print commands everywhere. It's brilliant.
It's the JavaScript way, right?
I think it's the developer way, isn't it? But anyway, so we did have one other question which I wanted to just touch on, and then we'll get on to the next session. But that was around Visual Studio integration. And when I was in session one where we were cloning to the local repo down to my machine, I used the command line to do that clone. But there is a drop-down box inside Azure DevOps where you can just go Visual Studio, and it will clone it straight into Visual Studio. That's supported, right now in Visual Studio 2019 and lots of previous versions. Visual Studio 2022, that's currently in beta, it was announced at Build that they're adding support for GitHub as well in the future. Now, I think we've only got one last question that's just popped in, Peter. I don't know if you've seen this. What's the recommended way of dumping out variables inside our debugging?
So you've got a couple of options that we can just echo them using Bash, for instance. You could use PowerShell. Equally, you could use GitHub scripts. So the action/GitHub script gives you access to a pre-hydrated bunch of framework APIs like you write in your own actions. So you could call core.info, core.error is available to log that information. It also gives you a little bit of an ability to potentially modify the contents. So you're just not dumping variables, you could do if conditions and things like that. So it gives you effectively a cut down actions environment as if you've written your own action step that you can embed and execute as you see fit.
That's awesome. Right, at which point I think why don't we go on to the next session and we'll carry on. Sounds good. Thank you. See you on the flip side.